We talked last time about solving linear equations, which are equations that have an x to the power of 1. Quadratic equations are equations that have x to the power of 2. The general form or standard form for a quadratic equation is going to be the following: ax squared plus bx plus c equals 0, okay, where a is not equal to 0. Okay. Otherwise, if a was equal to 0, what kind of an equation would you be dealing with? Linear, right? So here, when you're looking at these, there's 4 different rules that we're going to go through, okay, for factoring. And you kind of look to do it in this order or to see whatever's simplest. Okay, so the first is factor and use the zero product rule. Okay, that's what I'm going to talk about first. And this is a type of solution method that you look to use, especially if you have rational zeros on here. And so if you have a quadratic equation, and what you can try to do is look to see, can you factor this equation, set your factors equal to 0. Again, the zero product rule is if you have the product AB equal to 0, then you can either set A equal to 0 or B equal to 0, and that has to be true. One of those has to be true for that. And so if you set everything on one side of the equation and set it equal to 0, okay, which is usually your first step in solving an equation anyway. So if we subtract this 4, move everything over. Okay, can you find factors of this expression and then set those factors equal to 0? And so when you're looking at this, again, you can do trial and error if you want. However, since your leading coefficient and constant are not prime numbers, it may be easier to rewrite the middle term. So if we take our leading coefficient times our constant, what's 6 times the negative 4? Okay, what two factors of negative 24 have a sum of this middle term's coefficient, positive 5? So a positive 8 and a negative 3. So if we rewrite our middle term as those two terms, and then factor this by grouping, what common factor can we remove from this first pair of terms? A 3x, leaving 2x minus 1. And what common factor can we remove from the second pair? 4, leaving a 2x minus 1. And so we accomplished what we were looking for. We have a common factor that we can remove. And when we remove that common factor, we're left with the terms 3x and a positive 4. Okay, and so here we've solved this by factoring, using all the rules that we went through in the chapters in which we factor. And now we can use the zero product rule, which says set each of these factors equal to 0 and solve. And now again, when you use the zero product rule, there's a real quick and easy shortcut for this, and that is when you're solving, you just take the opposite of your constant and divide it by your leading coefficient. So what's the opposite of negative 1? Positive 1, divide by the leading coefficient, 2. So one solution is 1/2. The other solution is going to be what? Opposite of the constant, negative 4, divide by the leading coefficient, 3. And so these would be your two solutions for this problem. Okay. All right, I want you just to very quickly see if you can solve this equation by factoring. In this problem, because your leading coefficient and constant are prime numbers, you probably can use trial and error pretty efficiently. You know the first prime factors for 3x squared are 3x and x. For the value 2, we're either looking at a positive 2 and a positive 1, or a positive 1 and a positive 2. Those are the only possible ones that we need to test. And so if we look at our outer plus inner products, here's our outer 3x plus our inner 2x. Does that have a sum of 5x? Yeah. So we found it on the first one. So these are the factors: 3x plus 2 and x plus 1. So you're going to set each of those factors equal to 0. Again, you can use the shortcut, which is take the opposite of your constant, divide by your leading coefficient. So one solution is negative 2/3. The other solution here, it's just the opposite of this constant, negative 1 divided by the leading coefficient of 1. So it's just that number itself. And that would be your solution.